ladies and gentlemen, here we go. We're going back to parametrics and vectors. Now, a couple things that are reminder. We did parametrics. We started with parametrics and vectors, and now we're going back to parametrics and vectors. And they are really simple. But if you remember, if I have the first derivative, which we talked about the first derivative dy dx, is dy dt divided by dx dt. Just like in polar, it was dy divided by dx d theta. dy dx is dy dt divided by dx dt. It doesn't matter if it's vector or parametric, it's the same thing. The second derivative is the derivative of the first divided by dx dt. The second derivative is the derivative of the first divided by dx dt. And I believe that we talked about that already too. Here we go. Here's what we haven't talked about necessarily. X prime of t, or dx dt, is the movement of the rate of change of x in the movement with respect to horizontal direction. Because how does x move? Left to right. So it's the rate of change with respect to the horizontal direction. Versus dy dt is the rate of change of the y with respect to the vertical direction. The velocity in the vertical versus the velocity in the horizontal. Now this should be like, oh yeah, that makes total sense. Vector notation. X of t, y of t, position. X prime of t, y prime of t, velocity. X double prime of t, y double prime of t, acceleration. Then we'd be like, yeah, that's right, Joe. That's a no-brainer. Got that. dy dx is the rate of change of y with respect to x, the slope of the line tangent to the curve, or the slope of the path of the particle. So when you're talking about parametrics or vectors, it's the slope of the path of the particle. D squared y over dx squared, second derivative, is the rate of change of the slope of the curve with respect to x. I believe that we had talked about both of these, but I'm going to remind you. Square root of dx squared plus dy squared, dx dt squared plus dy dt squared is the speed or the magnitude. That is your speed or magnitude of a velocity vector. Speed or magnitude of velocity vector. The integration of that thing is the length of the arc, or the distance traveled. Length of arc and distance traveled should recognize to be the same thing because it's how far you've gone. That's why it's the distance traveled. How far you've gone. Arc length looks pretty similar in everything that we've done. All of them have got a square root. All of them have a derivative squared, and they have something else. All of them have something else added to it. All right. First one. Find me the velocity vector for this vector when t equals 1. I tell you x of t equals t cubed minus 4t squared. Y of t equals 4t is t to the 4th minus t cubed. Go. There's a part A and a part B. Part B is acceleration. See if you've got the same thing that I do. should have gotten 11 and 1, yeah? Everyone agrees with my answer? Why not? Has to be in vector form. There's no vector there. I've got two numbers, but that doesn't tell me anything about it. Has to be in vector form. So I should have 11, comma 1. Now we're good with my answer. Yeah? Acceleration. Everyone got your acceleration? Let's find out. What, Jason? Oh, did I flip the X1? I did. Please make sure you're very, very clear on what goes where, because this is wrong. It better be 44, comma 36. Please make sure your X goes in the right space and the Y goes in the right space. Did I do my math correct? No. We're totally off. 20, yeah, 20. Because this is 19 squared. Oh, it is supposed to be 3t squared. You want to call me on that one? Oh my goodness. See what happened? Oh, like, yeah, Miss June, yeah. Uh-huh. Yeah. See what happens? Okay, so that's 9. That's 18.
No, it's not.
No, it's not 9, it's 6. 6, 6, 12, 20. How's that? Is that better? All of you are like, sometimes I make mistakes for a reason, and sometimes I literally just make mistakes. Most of the time they're for a reason. Alright, how about this one? Find me the magnitude and velocity. Flip it over. Find me magnitude and velocity. Still on calculator. Find me magnitude and velocity. Example number 2. You flip it over, literally straight up flip it over, you get it. Top left hand corner. X of t equals t squared plus 3ty equals t cubed minus 3t squared. Left sheet. Let's turn this before. Now, I do need to remind you, ladies and gentlemen, that please make sure you label x prime of t and y prime of t. You can use x prime and y prime if you want to. But don't just have 2t plus 3 and 3t squared minus 16. Because if you just have them and I have no clue what they are, I can't give you credit for them. So you do need to have labels on them. And so I know my velocity vector is 5, comma, negative 3. that. Do that math right. All right. Magnitude. Magnitude is the square root of dx dt quantity squared plus dy dt quantity squared. In our case, dx dt equals 5, dy dt is -3. There's magnitude. You believe it's radical? That says it can't be radical. Here's the next question. Particle moves in the direction of the xy plane so that x equals square root of 3 minus 4 cosine t, and y equals 1 minus 2 sine t. T is between 0 and 2 pi. The path of the particle intersects the x-axis twice. The path of the particle intersects the x-axis twice. Random expression represents the distance traveled by the particle between the two x-intercepts. Now the value. So talk to your group members and see what you think about what you need to do first.
Work with your table. Yes, what do you think? Oh, 0 to 2, yeah,
Ladies and gentlemen, you know how to start this? Need help? Yes, no? Hey, Esau, what did you tell me you know how to do?
I said y equals to 0.
Why?
Because that's when it intersects the x-intercept.
I love that idea. Love that idea. Many years ago. I used that extra.
5 or 6.
Alright, let's see how we did. Ladies and gentlemen, figure out where they intersect. 5 or 6 and 5, 5 or 6. It is the square root of dx dt squared plus dy dt squared. And it said you did not have to simplify. So I didn't. Do not evaluate. So I didn't. do not have to simplify. You can leave it like this. Don't simplify. Don't make it more complicated for yourself. The next one says particle moves in the xy plane so that the position is given by x of t and y of t, where t is greater than or equal to 0. What values of t is the particle at rest? Talk to your partners. Yep. Yep.
Oh,
Yeah. That's the kicker. Because it says don't evaluate. If it had said I need to evaluate, then I need to do something else. Yeah, because there's no way to simplify that nicely. Because if they were both fours, then I could simplify it nicely. But not.
I know it's like really close to like
Thursday the 18th. Part 1. And then there's a partner loss exam.
oh.
That's all partner.
Plus
And then Saturday the 20th. That's all straight on. You are third period is on Monday, Monday and Thursday. Get everybody Well, they're all focus points and they're actually all Yep. But by the time you take that note, all right, let's see what we got. So you should have gotten, you got this, and well, you may have gotten this. You may have just said, well, then dy dt has to equal 0, right? Or you were like, oh, dy dx has to equal 0, dy dt has to equal 0. Here's the difference, ladies and gentlemen. This particle is moving left to right and up and down. In order for it to be at rest, both have to be equal to 0. In order for you to be at rest, in order for the particle not to move, they both have to be 0. If dy dt is equal to 0, I can still move left to right. I'm just not moving up and down at all. If dx dt is equal to 0, I can still move up and down. I'm just not moving left to right. But in order for you to be at rest, they both have to equal 0. What do they both equal 0? T equals 2. They both have to equal 0 in order for this to work. Alright. Here we go. Particle moves in the xy plane such that its velocity vector is such. And I tell you the position vector at t equals 0 is 7, negative 4. Find me the position at particle t equals 1. Find me the particle at t equals 1. How do I find position from velocity? Integrate. Oh, there's an initial condition. That's an initial condition. That's important to know. Oh, because I have a plus instead of a minus. I have done everything today. That's a plus. That's this is a carrying through with your stupid not rewriting correctly. So that's a minus sign, which means this is a minus sign. Makes it a 6. There we go. Now you'll notice you could have done plus C's and then plugged in. You would have done plus C's, that's fine. I just did initial value. You have an initial value. Why do the work with the plus C and not plug in? Why don't you just use your initial value and go from wherever that initial value started to the value that you want? So much easier that way. But the other way, doing plus C's will work. We okay with this? Alright. Here we go. Now this is a calculator question. This is a free response. It is a calculator question. I am going to give you about 3 questions, 10 minutes. Go for it. It is a tiger question. There we go. Come back. There it is. Alright, so ladies and gentlemen, a couple things. Here, there's my timer. Here's what I should have. You do not, it is a calculated question. You do not have to show the derivative of this. You can literally say, I am taking the derivative of the sine of t cubed, evaluating it at t equals 2, and I got negative 1.746. Use a calculator. Don't take the actual derivative. Let the calculator do the derivative evaluating. d over dt of the cosine of t squared at t equals 2 is 3.0272. So my actual acceleration vector is negative 1.746, comma 3.0272. Let the calculator do the math for you. Don't do it. Equation of a tangent line. What do you need to write an equation of a tangent line? You need slope and point. Do I have either one right now? What do you have? The point is what? Now I need to find dy dx. By the way, that would be dy dt divided by dx dt. So that would be the cosine of t squared over the sine of t cubed evaluated at t equals 2. Cosine of 2 squared over sine, oh, I totally did that wrong, of 2 cubed. Let me fix this because that's not where my square goes. That's square. Y minus 4 equals negative 0.6606 times x minus 1. Again, let your calculator do the math for you. There is no reason to do that math. Let it do it for you. Part C. Find the speed of the vector. That is the sine of 2 cubed squared plus the cosine of 2 squared quantity squared. Let's see. Square root. Sine of 2 cubed. That close that's squared plus cosine of 2 squared. Close that, squared. Again, ladies and gentlemen, I literally just wrote down what I typed in, and I don't have to do any more work. I'm good with that. And then the last one, find the position of the particle at time t equals 1. Somebody's like, well, how do I do that? This is literally a calculator question, because you can't integrate the sine of t cubed without a calculator. Oh, did I give you units? If I did not give you units, you're not giving me units. If I give you units, you better give them back. Position particle. I know at t equals 2, I have the order pair 1, 4. If you integrate x prime of 2, t, from dt, from 1 to 2, do you agree that that gives me x of 2 minus x of 1? Everyone okay with me saying that? Here's the issue. What am I looking for at x at 1? I'm looking for this piece right here. X of 1, ladies and gentlemen, is x of 2 minus the integration from 1 to 2 of x prime of t dt. Make sure you have it set up correctly. Because it's the second number, not the first number. Right? That's the difference. Or it's the first number, not the second number. I said that wrong. It's the first number, not the second number. So be careful that you have it written correctly. So at t equals 2, I know that this is 1 minus the integration from 1 to 2. What was it? Sine of t cubed dt? Sine cubed. 1 minus integration from 1 to the sine t cubed dt, or dx. Your first one. So x of 1 is 0.78189. Y of 1 would be y of 2 minus the integration from 1 to 2 of y prime of t dt. Y of 2 is 4, so 4 minus the integration from 1 to 2 cosine t squared dt. 4 minus integration from 1 to cosine t squared. So y1 equals 4.443. I'm good, yeah? No, because I still have to do what? Put it back in form. I didn't actually answer the question. I did all the work, but I didn't actually answer the question. So in vector form, it is 0.78189, because you know I like to go more than 3, and 4.443, or 0.782. 0.782 and 4.443. And we're okay with that. All right. In your stuff from before, not the packet. Well, actually, there's two things. Take out the packet. The folder, vanilla folder. Take out the vanilla folder. Take out the vanilla folder. Find the one that says big review, Big 10, big review. Units 1 through 8. Big 10 review. Units 1 through 8, not calculator active. Find the Big 10 units 1 through 8. Big 10 units 1 through 8. And then in your other stuff, find me your two worksheets that had vectors. One was a circuit and one just was a single worksheet front and back. That you have parametrics and vectors. Find me you got it from before. This was not in the folder. This was homework, day 1, day 2. Remember we did this, we did a circuit, we didn't do the entire circuit. Now we're just, yeah, that worksheet, take that one out. The single worksheet had the circled ones you did, and then you had a vector, parametric vectors, and yeah. We're going to finish that today, lunch class. There's a worksheet that says parametrics and vectors. It's a stapled worksheet. You've finished part of it already. So you're finishing that for homework. You're doing the Big 10 review that I handed you, that you got. And then I'd like you to start on, and you are not finishing, starting on the single worksheet that, the one that you did the circle one, you're doing the non-circle one. Remember the worksheet that you did circle one? Now you're going to do non-circle. That's not due for 2 classes. Yeah, which you should be able to finish now, like in class. Or pretty close, because you got 15 minutes. So you should be able to be pretty close to finishing the circuits. You're finishing the circuit, you're doing the Big 10 worksheet, and you're starting the singleton worksheet. The circuit, you should be able to finish the next worksheet. So really, the Big 10 worksheet that one. So really, you should have the Big 10 worksheet, and you do have a take-home quiz. That's why I put WebAssign this time. You do have a take-home quiz. It is on WebAssign this time. But right now, I want you to do finish the circuit on parametrics and vectors. Finishing the circuit on parametrics and vectors.